Hey everyone, and welcome. Today, we're pulling back the curtain on the master plan behind some of the world's most complex technology. We're going to deconstruct the blueprint that makes sure a system does exactly what it's supposed to do every single time. So, let's just dive right in.
Really think about that for a second. We're talking about things like a new airplane, a massive financial trading platform, or a critical national security network. The stakes are just unbelievably high. So where do you even begin with something that huge?
Well, the answer is you start with a blueprint, an incredibly detailed blueprint. In the world of high-stakes engineering, that blueprint is called the System Subsystem Specification, or SSS for short. And believe me, it is the foundation that everything else is built on.
So here's our roadmap for this little tour. We'll start with what an SSS actually is. Then we'll look at how it paints the big picture for the whole project. We'll see how it connects to the outside world, and then we'll dive into its inner workings. And after that, this is the really cool part. We'll get into how you prove it all works before we wrap up with why this blueprint is just so valuable.
Okay, first things first. Let's get a really clear handle on what this master plan is all about.
Okay, so the official definition says it's a formal document that specifies requirements. But here's the kicker. It also specifies the methods to be used to make sure each requirement has been met. You see, it's not just a wish list. It's a plan that has the final exam built right into it from the start.
And that's the key thing to get. This is not just some technical document that's going to sit on a shelf gathering dust. No way. It's a binding contract between the folks who want the system and the folks who are building it. It's a step-by-step guide for the engineers, and it's the final checklist everyone uses to agree that, yep, the job is done, and it's done right.
So before you can even think about a single line of code or one piece of hardware, the SSS has to set the stage. It all starts by defining that big picture.
Right from page 1, this document nails down the absolute basics. What are we calling this thing? What version is it? Why does it even exist in the first place? It even lists every other document that's related to it, which creates this single source of truth. Now, this isn't just bureaucratic box ticking. This is all about preventing the #1 project killer, ambiguity. Everybody is on the exact same page from day one.
All right, we've got the big picture. Now let's talk about how the system actually connects to the outside world. We do that through what are called external interfaces. It sounds kind of obvious, right? But this is one of the most common places where complex projects fail. If your system can't properly get information from the outside or send out its own commands, it's really nothing more than a very, very expensive paperweight. The SSS is designed to stop that from ever happening.
And this is where it gets wild. Look at this level of detail. To define just one single piece of data that flows into or out of the system, you have to specify everything. Its unique name, its format, its units, we're talking meters or nanoseconds or whatever, how precise it needs to be, and even who's allowed to see it. It is unbelievably thorough.
And it's not just about the data itself. The SSS also defines exactly how that data moves around. Are we using a specific radio frequency? What's the transfer rate going to be? How is the message encrypted? Every single one of these little details is locked down to prevent that classic, well, it worked on my machine problem when you have different teams trying to connect all their work together.
Okay, so we figured out how the system talks to the world. Now let's pop the hood and look inside and see how the SSS defines what the system must actually do and, maybe just as importantly, how well it has to do it.
This is brilliant. These are the system's quality factors, but I just like to call them the essential abilities. See, it's not enough for a system to just work. It has to be reliable. It needs to be maintainable and available when you need it. And each of these isn't just some vague goal. It's a totally measurable requirement defined in the SSS. This makes sure that quality is built in from the ground up, not just bolted on at the end.
And beyond those qualities, the SSS goes even deeper. It specifies safety protocols, all the security requirements, the exact environmental conditions the system has to survive in, like extreme heat or radiation, and exactly what computer resources it's going to need to function. Absolutely nothing is left to chance.
Okay, this brings us to what I think is the most powerful part of the entire SS document. Because, it's not enough to just write down 1,000 requirements. You have to prove that you've met every single one. And this whole process is called qualification. This quote from the source material is really the heart of the whole process. It says it all. For every single requirement we've talked about, the document must also state the exact method that will be used to prove it works. So how do you do it? Well, there are 4 main ways. First up is demonstration. This is the simple show me proof. You just operate the system and watch it do its thing. Next is test. This is way more rigorous. You run the system, but you use instruments to collect hard data that you can analyze later. Then you've got analysis. Here, you're crunching the numbers from tests or simulations to prove a requirement, like calculating a wing's stress tolerance. And finally, there's inspection. Sometimes you just need to look. You visually examine the hardware or the code or the docs to confirm it matches the spec.
And here's the aha moment. If there's a requirement written in that document, it is directly tied to one of those 4 methods of proof. There are no nice-to-haves or fuzzy goals. Every single statement is verifiable and has to be proven. This creates absolute total accountability. No exceptions.
And the final piece of this puzzle is traceability. Think of it like a golden thread. It links a big, high-level requirement, like the system must be secure, all the way down to the specific lines of code and hardware parts that actually make it secure. This guarantees that nothing important gets forgotten or just lost in translation between teams.
So, after all that incredible detail and all this formal structure, what's the big takeaway here? I mean, why would anyone go through all this trouble?
Because the SSS is so much more than just a document. It's the main communication tool that lets the software team, the hardware team, and the safety team all speak the same language. It's the contract that protects both the client and the builder. And at the end of the day, it's a massive risk reduction strategy. It's literally the recipe for success.
Yeah, all this upfront work, defining every detail, every interaction, every proof, it might seem slow at the beginning. But what it really does is prevent incredibly costly misunderstandings and failures later on. It's the discipline that ensures the final product is safe, reliable, and actually does what it promised to do.
And that kind of leaves us with a final question to chew on. In our modern world of moving fast, of agile sprints and rapid prototyping, does this kind of deliberate, painstaking, detailed blueprint still have a critical role to play? Does it still hold the key to building things that don't just work for a little while, but are truly great and built to last? Something to think about.